Hello everyone. Till now we have discussed about the linked list insertion, deletion and traversal. We have seen how to delete the elements from the beginning, insert the elements at the beginning, insert the element after the given node, and insertion in the end. And finally we have traversed the linked list just to check if my linked list is working fine. Today we'll learn about the ascending order linked list. To understand the ascending order linked list, we will first have to change the insert after function. So please see what are the changes being made to the insert after function. Earlier we used to implement insert after function considering that we have the address of the first node. Along with this we were considering that a key value is given, and after this key value we have to insert another node containing x key value. So we are not going to change this, and while calling to the insert after function, I will first search the address of the node 400, and then after this I will insert a node 350. So instead of passing the key value 400 and then inserting an element after this node as 350, we will only pass 350 information, and before this we will try to find out the address of the node containing 400. So let's take a temporary pointer. Let's say t is the temporary pointer, and let's say before finding out the address of the element containing element 400, let's take t at the first node and then traverse this linked list while t.info is not equal to 400. The moment we find that we have a node which is having information 400, we will break. Okay. Now once we have the address t, which is the address of the node containing information 400, rather than passing the address of start, we will now pass the address of t and will make the insertion. So only two parameters are passed now in the insert after function. One, the address of the node after which we have to insert, and another one, the information which is to be inserted. So let's go to the insert after function, wherein we are not finding the address of the node containing information. That information is already given to us. So let's say there is a temporary pointer which is containing the address of the node or address of the target node and a key value x which is to be inserted. We have taken it a double pointer because we are going to make changes through this function. So if we are going to make the changes, call by reference will be done, and since we are passing the address of a pointer, it should be accepted as the double pointer. After this, we have taken a node by calling a getNode function. We have inserted an information x here, and then suppose this was the linked list, and in this linked list after 400 we have to insert 350. So the newly created node is containing information 350. First we will have to link this 350 node with 300, and then we will link 400 with 350. So you can see that the 400 node has the address 10 containing address star 10, and then this node 350 is having address p. So if this 400 node is having address star 10, 300 will have the address earlier before the insertion, means let's say this is not existing. So 400 and 300 would be linked up. This node will have an address star temp dot next. 300 will have the address star temp dot next. Now from our side we have taken a node 350, and let's say the address of this node 350 is P. So first we will link up this P node with 350, means P dot next will keep the address star temp dot next. So P dot next will keep the address star temp dot next, and then star temp dot next means this node is star temp node. Next field of this node will contain the address P. So star temp dot next equals to P. So this way the insertion would be completed. Let's disable the another insert after function and work with this one only, just to check if this is working fine. We are disabling the deletion functions also. We just want to see if this insertion function has worked fine. Okay, so since already we have this start, and we do not need to define it again, and this one also is not required. We need to define T. This will be pointer to struct node. Hopefully this will work fine. Yes. Let's see. Mistake has actually taken place. Here will be next. And you see that after 400, 350 has got inserted. Now suppose we have to create the ascending order linked list. So ascending order linked list will be using some functions. Those are insert beginning and insert after. So for the time being we are actually disabling all these functions: insert beginning, insert end, then traverse is required for us, and then delete end also, we do not require it at this time. So any function that we do not require, we're disabling those functions. Callings are also going to change. Let's say there is a function which is known as ascending insertion. We will pass something to this. We'll find out what is to be passed. Let us try to define this function. Ascending insertion. So obviously for the insertion in this ascending order linked list, we need to have the address of the first node. So since we are passing the address of the first node, a call by reference, so it should be double star. And let's say there is a key value x which is to be inserted. So two parameters in this ascending order linked list. Suppose we already have some elements in this ascending order linked list. Let's say these are the elements. Now to insert an element, let's say 250, we will have to find out where to insert 250. Obviously this will be inserted in between 200 and 350. So we can also say that if you have to insert 250, this will be inserted after 200. So we will first have to find out the appropriate position for the insertion. To do so, let's say we have a pointer P which is at the first node, and let's say we have Q also, which is the previous node of P, predecessor node of P. Since P is initially pointing at the first node, P is keeping the address of the first node, so there is no predecessor of this P. In that case, Q will be null. We will have to check the element 250 which is to be inserted. Here it is X. If this 250 is greater than 100, so I will move to the next node. Means P will progress to the next node. P comes here. Now Q has to be predecessor of P, so Q has to progress as well. Q was earlier null, so we are now giving P to point at the first node. Now 250 is again more than the information of P node. Information of P node is 200, X is 250, so we will again progress P to point to the next node. At the same time, Q will also progress to the next node. Now 250 is not more than the information of P, which is 350. That means we now have got the appropriate position for the insertion. And the appropriate position for the insertion is after the node Q. Fine, after node Q. Let us write this much at least. So what we are doing here, we are finding the appropriate position for insertion. So first say we have a temporary pointer T. T starts from the first node, and we are actually finding out where to stop. Here it is not T, it's let's say P. Let's say there is a Q as well, and P starts from the first node. Initially, when P is at the first node, Q will be null, as discussed earlier. Q is always the predecessor of P node. So while P is not equal to, while P dot info you can say that while X is greater than or equal to P dot info, we will move to the next node. Means P equals to P dot next. But before moving ahead to the next node, Q equals to P. Means we have to progress Q as well. Not only P has to go to the next node, Q also has to go to the next node. So since Q has to be at the previous node of P, so if we are moving P from this node to this node, before moving, Q is made equal to P such that it remains previous node of P. So once we have found the appropriate position for insertion, for example here, X is 250, which is not more than the information of P node. So now we can insert after Q node. So we can call the function insert after Q node the information X. But since we are making changes through this function, so address of Q will be passed. So this is one of the case. Suppose we take another case wherein we have to insert 450. So to insert 450, let's say we have already checked this much condition. So since 450 is greater than information 350, so we will move to the next node. Now 450 is more than the information of P node, which is 400. So we will again move these two pointers ahead. And now we will again check the information of P node with 450. So 450 is not greater than or equal to 500 node. So means that we have found the appropriate position for the insertion. It means we can insert the node after Q node, means after 400, 450 can be inserted. Let's take another case wherein we have to insert 50. So for insertion of 50, we have the condition like we have initialized this Q to point at the first node, to point as null, but P is pointing at the first node. Now X has to be inserted, which is 50. Once we check X with the information of P node in this condition, X is not greater than or equal to information of P, because information of P is 100. X is less than this. So the loop entry condition fails. It means P remains at the place where it is and Q remains at the place where it is, and Q is actually null. So we will have to insert 50 at the beginning of the linked list. Fine. So we have to insert 50 at the beginning of the linked list and not after any node. We can identify this by checking the Q. If Q remains null, it means we have to insert as a first node. If Q is not null, Q is pointing to the valid node, it means we have to call the insert after function. So we can include this condition here. After this loop has finished, we can check if Q is equals to null. Actually, we have to insert in the beginning. We have to insert at the beginning of start. This may be a bit confusing, but this is actually the true value. We need to pass the address of start and we have to insert X here. Otherwise, we have to do this change. So insert beginning if Q remains null, and insert after if Q is not. Fine. So we can check this function by calling calling this function with some of the values. So address of the start, and let's say 100. Fine. Suppose we are calling it for the first time and start is null. So if the start is null, P is null, and along with this Q is also null. But when we are in this condition, we have to check the information of P node with X. If P is null, if a start is null, obviously P will be null, P will be initialized to null. So if P is null, means we cannot check the information of P node, we cannot compare it with X. So if P is null, we cannot make the comparison. So here we are adding one more condition. While P is not equal to null and X is greater than or equal to P dot info, we are doing this. So it will work for the first time insertion. If P is null, comparison is not possible. If comparison is not possible, no need to execute the body of this loop. Come out of this loop. And if Q is null, obviously if P is null, Q will also be null. Insert in the beginning. Otherwise insert after the given node. Let's call more insert functions. Let's insert 200. Let's insert 300. Let's insert 50. Let's insert 20. Take another one. Insert, let's say 250. Okay. Suppose we are taking this condition where we already have 100 available in this ascending order linked list, and we have to insert 200. So what we will do, we will start as Q equals to null and P here. And then when 200 has got compared with this 100, obviously 200 is more than this. So P advances to the next node and Q advances also to the next node. It means Q is at the first node now. And since we only have one node in this linked list, when P crosses this node, P becomes null. So if P has become null, it means we have to come out of the loop. You can see that if P is null, we are coming out of the loop. So this is working in this case also. And when Q is at the valid node, Q is not null, we have to insert after Q. Obviously 200 will be inserted after 100. So let's check if this function is working fine. No errors. And yes, you can see that we have got the numbers in ascending sequence. So if we summarize this, we start with taking Q as null. And we start P at the first node. Q node will always remain predecessor of P. If information to be inserted is greater than or equal to the information of P, we advance to the next node. Along with this, we are progressing Q as well. And if Q remains null, it means we have to insert in the beginning. Otherwise, we have to insert after the node Q. Once this condition is over, we can check if this function is working fine by calling the traverse function. There are two conditions which may arise. My linked list is empty initially, and we have to insert the first node. So we have made the initialization like P is at the first node and Q is null. So since linked list does not contain any element in the beginning, P will be null. If P is null, we have added a condition here. No question of comparing the information of P node with X, because P is not existing. So we will come out of this loop, and since Q is null, we will insert in the beginning. And suppose we are going to insert an element which is more than every other element in the linked list. In that case also, while moving P and Q forward, sometimes P becomes null. If P becomes null, no need to make comparison between P and X. Come out of this loop. Obviously Q will be at the last node, so insert after the last node the information X. Thank you.